Hey seniors, today is going to be a crash course in doing all operations in scientific notation. So just follow on with the video, take notes. This will be a good reminder of some things. So remember, when I'm adding and subtracting in scientific notation, my exponents absolutely have to be the same. They absolutely have to be the same. So this is where I have to remember my good friend Lars, that if I have to change my exponents, that's how I move it. So let's go ahead and do our first example. Go ahead and write this in your notes page. 3.1 times 10 to the negative fourth minus 1.6 times 10 to the negative fourth. The first thing I look for is, are my exponents the same? Negative 4 and negative 4. Yep, they are. So then if my exponents are already the same, all I have to do then is deal just with my coefficients. So all I have to do is subtract 1.6 from 3.1. Always line up your decimals. 6 cannot be subtracted from 1, so I'm going to cross that out, go next door and borrow, and turn this into an 11. I'm sorry, a 10. Whew, long day. 10 minus 6 is going to leave me with 4. 2 minus 1 is going to leave me with 1. So my new coefficient is 1.4 times 10 to the negative fourth, because I always keep my exponent that's the same. Let's do another example. If I had 4.84 times 10 to the fifth plus 7.42 times 10 to the fourth. Again, I look, are my exponents the same? 5 and 4, they're not, so I know I'm going to have to change one. The one that I don't choose, the one I always keep the same, is the one with the larger exponent, which is 4.84 times 10 to the fourth. So I'm dealing just with 7.42. If I want to add one to my exponent, this is where I have to remember my good friend Lars. If I want to add, I have to move my decimal left. So let's go ahead. If I move it one spot to the left, I can add 1. My new problem is 4.84 times 10 to the fifth plus 0.742 times 10 to the fifth. Now, my coefficients, I can just deal with them because my exponents are the same. So all I have to do is add my coefficients. 4.84 plus 0.742. Line up your decimals, fill in your zeros. 0 plus 2 is 2. 4 plus 4 is 8. 8 plus 7 is 15. Carry my 1. I'm coming out with 5.582 times 10 to the fifth. Always keep your exponent. So that's adding and subtracting. My exponents absolutely have to be the same. Let's do some multiplying and dividing. Let's do an easy one for division. 6 times 10 to the fifth over 3 times 10 squared. If I'm multiplying or dividing in scientific notation, my exponents do not have to be the same. I don't care what they are. All I have to remember is my MADS rule. If I multiply, I add. If I divide, I subtract. So since I don't care about my exponents, I can go ahead and work just with my coefficients. 6 divided by 3 is going to leave me with 2. If I'm dividing, I subtract my exponents. 5 minus 2 is just 3. So I'm left with 2 times 10 to the third. Let's do one where we multiply. All right, if I had 9 times 10 cubed times 2 times 10 squared. Again, I don't care about my exponents. They don't have to be the same. I just got to remember my MADS rule. So then I can just work with my coefficients. 9 times 2 is 18. And then if I'm multiplying, I add my exponents. 3 plus 2 is going to leave me with 5. Now, something should be screaming out at you. Miss Abel, this answer is not in proper scientific notation, which is correct, because my coefficient of 18 is not between 1 and 10. So I'm going to have to remember my good friend Lars and move my decimal and add 1 to my exponent. So I know I have an invisible decimal at the end. If I move it one spot to the left, I can add 1 to my exponent. My new coefficient is 1.8 times 10 to the sixth. And since this answer is in proper scientific notation, we are done. All right, guys, that's going to be it for today. Let's go ahead and practice.